Hello my friends from Hatari Water. This time we are going to do a quick tutorial, very interesting tutorial about how normalization affects the accuracy of neural networks. This is actually an exercise that we have done from a research, from a paper from our friend Eduardo Oyage. Let me show it to you. Okay, so we have this research where is the relationship between aquatic invertebrates, water quality, and vegetation on Indian peatlands. Okay, this is a very interesting paper on the Peruvian Andes where there is some wetlands, and from these wetlands there is some, and then we are going to the bottom of this research because there are some data over wetlands. We have used just the wetlands on the dry season because we are more interested in to know which is the effect of groundwater. Mhm. And groundwater will be present only, I mean, will be only present on the dry season. Meaning that on the wet season you will have a mixture in between precipitation water and groundwater. Okay, we have this is the chemistry data. Yeah, water chemistry data. So we have pH, conductivity, alkalinity, phosphorus, potassium, and so on. And these are, well, the species that they have found. And this is, there are some diversity index here related to some stations on the dry season. Okay, so we are going to define how normalization could affect the accuracy in between a neural network that will try to represent the the chemistry into an index of like maybe abundance of all vegetation. Okay, so what we will do is first we import. With this we will use pandas and numpy. We will import the chemistry data here, and we import it, and then we imported as well the species data here, and then we import it. And please note that we do a transverse of the matrix because like we wanted the data in another order. Okay, then we generate a data frame with the same index as the species because we have on the paper we have that we have for the dry season we have like 4 6 no 4 8 12 18 points, but only for the dry season we have data of 14 points, so that's why we need to make it compatible. So with this code we make it compatible, and then we normalize the data. We have done three sets. Like the first one is the original data, then is the data divided by the sum of all data, and the last one is the data divided by the mean of all data for a column. So what we will do is that we have extract of our input data here, and this is the data normalized by the sum, and this is the data normalized by the mean. Okay, so we run this. Then we define a function of neural networks. We do it as a function because we want to represent many cases of what will happen with the neural network. So we have here the chemistry data, the species data, how many neurons do we need, which is the learning rate, and the number of iterations. And this is defined as a function, and it gives back the value that is the collection. This function all is generating the neural network plus is generating the results of all the is generated the neural network, and as well is generated the results of all the networks. I mean, that this generates a neural network, and plus the function as well predicts all the values for the whole combination of chemistry. Yeah, and then we create an interactive plot. So we want to see, we run this as well. With this interactive plot that is made with functions of IPython, we want to see which is the best normalization in order to have the higher accuracy, the more accurate plot, because like what is for these machine learning algorithms, like you have to be sure which is the parameters, how sensible is your data, and even that you have to see if the computer will learn something about your data. So in order to do that, we need to normalize, we are going to see here if normalization is good, and plus like which is the method to normalize the data. So we run this, and then we will compare the chemistry data with this column that is the abundance of all vegetation. Okay, so here we have, this is the data with the original data for 400 neurons with a learning rate of this one plus a number of iterations of almost 5,000. So I think I will decrease my number of iterations, like maybe to 2,000. But sure it won't help much, but it will make my code more faster. Okay, the number of species is only one because it's actually not, I cannot not select to any place. And the learning rate, I will, let's wait because it's running. Maybe I should try to think in a better way to run it, maybe to serialize the processors and so on. Okay, cool. So if you see, the original data is not giving you any results. The normalized data, the data divided by the sum of the whole column as well. But if you divide it by the mean, like maybe you see like kind of more more exactly, no? Okay, so we will increase the learning rate because we wanted like the computer to learn faster, and as well as we see here like the equalitarian, the normalized by the mean is the one that has some trends. So I will maybe increase more. Cool. So we have here like a good approach that says that if you put the original data without any pre-processing, like the computer won't understand what is going on, because on your original data, this is the original data, you will have columns that goes from 100 on the range of the 100, this is in the range of the units, this is in the range of the dozens, and this is on the range of the decimal. So if we do not normalize the data, like the computer will have to learn by itself that this value is higher than this one. But both are related. The concentration of phosphorus are some variation on the phosphorus concentration will be harmful for the ecosystem, as well as, but it doesn't matter that this a concentration that will be on the 100% or something like that. I mean, it's a fraction. Okay, maybe you will understand, maybe not. Okay, so here we are. I mean, let's see if we put less neurons. Let's see what happens. I mean, less neurons maybe won't give you much, but as well, it will make the process to run faster. We are increasing our learning rate. Okay. Okay, cool. I like this one. Maybe looks better. And then maybe let's try to find more. Okay, maybe doesn't. They do not work with the whole iterations. But the purpose of this tutorial is to show that 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 a computer could give you some statistic, but it's really important how you put your data on the neural networks. Otherwise, the computer won't be working so fine. Okay, as long as we have seen here, like the egalitarian, I mean divided by the mean, is the only one that is giving us some results, while the others are giving us awkward results. So I will, these are the data, and these are the, I mean, on the description of this video, you will find the paths to the scripts, plus the plus this paper, and plus the process data as well, so you can reproduce this on your computer. Okay, I hope that this will be helpful for you. As long as we have seen the egalitarian approach is the best normalization that we can give for this example to our data. And please follow us by Facebook, Hatari Water, Twitter, Hatari Water. Please follow this YouTube channel, and we hope I will leave you my email. My email is this is my email. So if you have some problems with, I mean, if you want to represent something with neural networks, we will try to help you, or maybe have these interesting tutorials that will be much fun to resolve. So really thank you for your time, and we hope to see you on our next video. Thank you.